Hi students, now we are going to see the next application of dimension analysis. This is our next application, deducing a relation among the physical quantities. What is deducing relation among the physical quantities? Actually, in physics we have so many physical relations like F is equal to ma. This is one equation, and this equation actually gives us an equation for force, and F is equal to mass into acceleration. And in this equation you can see that power of m is 1 and a is 1. Then can you tell me another equation? Yesterday we have seen this physical relation, that is tau is equal to I into alpha. Here also power of I is 1 and alpha is also 1. So by using the dimensional analysis, the idea of dimensional analysis, we can deduce relation among the physical quantities. Actually, for that purpose we are using our homogeneity principle. Yesterday we have seen about homogeneity principle. What is homogeneity principle? According to homogeneity principle, we can check the correctness of the equation, and it follows like this. What is the homogeneity principle? A physical relation is dimensionally correct if the dimension of all the terms involved in the equation are having the same dimension. That is our homogeneity principle. So actually, to deduce relation among the physical quantities, different physical quantities, we are using this homogeneity principle. And let us discuss in detail about this. For that, we have to keep some points in our mind. First of all, this is the first point. To deduce a relationship, we are going to use the homogeneity principle. Homogeneity principle is used here. Then second one is, in order to deduce a relation for a physical quantity. Suppose, let us take this example. Suppose if we want to find this relationship, we must know what are the factors on which this force F depends. Only then we can find that relation. Only then we can find that relation. This is very important. We must know the factors on which that quantity depends. So let us consider one example, then it will be more clear. Here let us try to find an equation for centripetal force. So in order to find an equation for centripetal force F, we must know the factors on which the centripetal force depends. Centripetal force means when a particle of mass m moves in a circular path, the force associated is known as centripetal force. Let m be the mass of the particle. It is moving in a circular path with a velocity v, and the radius of the circle is taken as r. So from this we can find the factor on which F depends. We can write it like this. F is directly proportional to, it depends on mass, it depends on velocity, and it also depends on radius of the circular path. Then, but we are not sure about the power of m, v and r in this equation. Sometimes power of m can be 1, it can be 2, and power of v can also be 1, 2 or 3, and r's power can also be 1, 2, 3, 4, 4. But we are not sure about the power of m, v and r in this equation. So for instance, let us take the power of m as a, and power of v, let us take that as b, and r raised to c. Then to find the correct equation for the centripetal force, we have to find these values for A, B and C. So let us find what are the values for A, B and C. Before that, let us write this equation as, let us remove the proportionality sign by introducing a constant. Let us take K as the constant. So this equation can be written as F is equal to K into M raised to A, V raised to B into R raised to C. Then here the value of proportionality constant K is taken as 1. So this equation can be written as F is equal to M raised to A, V raised to B into R raised to C. As I told you, we are using the homogeneity principle to find this relation for centripetal force. So let us write these physical quantity is in terms of their dimensions. So what is dimension of force? Dimension of force is M L T raised to minus 2. This is the dimension of force. We are going to write a dimension of all the physical quantities. Dimension of M. What is the dimension of M? Capital M. Power is A. Then V is velocity. Its dimension is L T raised to minus 1 whole raised to B. Then R is radius. So its dimension is L raised to C. Then this equation can be written as M raised to A, L raised to B, T raised to minus B into L raised to C. On the left hand side it is M L T raised to minus 2. So this is equal to, we can write this as M raised to A. Here we have L raised to B into L raised to C. What is that? L raised to B plus C. That is A raised to M into A raised to N is A raised to M plus N. So L raised to B into L raised to C is L raised to B plus C, and T raised to minus B. That is equal to ML T raised to minus 2. So now we got this equation. Now let us compare the dimensions of similar quantities on both sides. That is, here let us compare M on left hand side and M on the right hand side, and let us compare and let us find the value of A. So by doing like that, M raised to 1 is equal to M raised to A. So what is the value of A? A is equal to 1. Then similarly let us compare the other terms. So next is L raised to 1 is equal to L raised to B plus C. So we can write that as 1 is equal to B plus C. And comparing this T raised to minus 2 and T raised to minus B on both sides, we will get B as minus 2 is equal to minus B, or B is equal to 2. And let us put the value of B here so that we can find C. 1 is equal to 2 plus C. So C is equal to 1 minus 2, which is equal to minus 1. So now we got all the values of A, B and C. A is equal to 1, B is equal to 2 and C is equal to minus 1. So let us substitute the values in this equation. Let us mark this equation as 1, and we are going to put the values of A, B and C in the first equation. So it will become F is equal to M raised to A. What is the value of A now? It is 1. Then V raised to B. What is B's value? It is 2. So it is V square. Then R raised to C. C is minus 1. So R raised to minus 1. So we got the correct powers of M, V and R by using our idea of homogeneity principle. If this equation is dimensionally correct, then dimensions of all the quantities involved on both sides must be the same. So we got this relation f is equal to mv square r raised to minus 1. It can be written as f is equal to mv square by r. This is the equation for centripetal force. Centripetal force f is equal to mv square by r. Actually, we are not sure about this relation, but we found this relation by using the homogeneity principle. In order to find the relationship, we must know the factors on which that quantity depends. If you know that, then any relationship can be calculated. This is how we calculate the relation among different physical quantities.